Okay, let's do another problem. Let's do the same system of equations, but let's say that they all interact this time. So we're going to have to break up all the angled vectors into their x and y components and then work to, that's the strategy. First, break up your angled vectors like this one, and this one into their x and y vertical and horizontal components. This one obviously is already vertical, so we're not going to have to do anything with that. But once that's done, once they're broken up into their respective x and y components, it's actually quite simple to cancel out and basically add and subtract them in their specific directions. So let's turn the black one into its x and y, and that will look like this. We'll draw that and essentially that too right there. And let's see, I didn't give them arrowheads, but I can. And let's see, I think I did it backwards, so I'll have to go like that and then say 50%, just so it's not so huge. And then I did figure out how to make the line dashed. I kind of like that. So I'm going to make this one dashed too. Dashed line and arrowhead, that's 50%. It's normal size. All right, so now that this black arrowhead has been broken up into its vertical and horizontal components, and remember, in case you missed it before, I don't know how many times I've explained this, but if the sun was straight up, it would leave a shadow. This angled vector would leave a shadow on the ground like that. And if the sun was going down, like setting, it would leave a shadow on the wall like that. That's how you calculate the x and y positions. So now that they're, this black arrow is being expressed as vertical and horizontal, we can get rid of it. So let's erase it from that way we're not confused and it doesn't look as complicated. Now let's say the red one. So I'm going to draw, in this case, I'll draw an line there, because if the sun was going down, it's almost like I'm asking you to imagine the world's upside down because the arrow's going down. But if the sun was over here, it would leave a shadow on the wall like so. Now let me give it its style. I'll say dashed line and arrowhead 50%. Sure wish it would hold on to those preferences. Okay, so now we'll do another line here, and we'll tell it to have an arrowhead on it. 50% normal size. Okay, so now that this angled vector has been broken up into its x and y components, we can get rid of it because it essentially exists in the form of x and y components. Now we need to do the last one, which is this green one. So let's draw an arrowhead here, and let's give it its characteristics, dashed line and arrowhead, 50% of its size. And then we'll do it again, another arrowhead here, and it's already dashed, that's good. Now let me just give it an arrowhead, 50% of its natural size. And since that is now represented like x and y components, we can get rid of it. So finally, we arrive at the point where we have everything in vertical or horizontal terms, so it should be pretty easy. I can see that this arrow right here, this red arrow straight down, is exactly the same size as the green arrow. So by all rights, we can delete that and that. They cancel each other out. Now, let's see. We could, if we decide to deal with the green one and the red one, we could look at it this way. We could say that they're going in the same direction, so they actually add to each other. So they're basically, the result of them working together is an arrowhead 4 squares long, 4 units of force long. This arrow is 5 units long, so it's essentially going to cause, you'd almost think of this as going to cancel out that much of the black arrow. So we need to shorten the black arrow. And as soon as we shorten the black arrow, this has been dealt with, it's gone, because that much of the black arrow also disappeared. They sort of annihilated each other. Now, since this vertical arrow and this orange arrow are in the same direction, they contribute to each other. So they essentially result in a much longer arrow. So at this point, we're just down to, I guess I could rewrite this. I could say that these combine, like I should get rid of the orange and extend the black arrow out to show that it has joined forces with the orange. How about that? I'll say it that way, and that way I can say this. We're now down to just one arrow in the vertical and one arrow in the horizontal, and so the result is going to be the angled vector that creates right there. This would be, we need to give it an arrowhead. That's basically the answer now. So 50%. And because we've expressed this vertical and this horizontal as an angled vector, we can now get rid of these two, kind of like the opposite of what we did earlier. So this is the answer to all those arrows that we started with interacting, is as if there was just one force pointing in this direction and this magnitude. Thanks for watching.